Here I show you two examples to show you the limitations like the C language or other, we call it low-level languages. The first example is if you want to generate if you want to write a subroutine or function to find the multiplication of two matrices, what do you need to do? How can you write such a function? Remember, this is the mathematical form to perform matrix multiplication. So if you want to implement this part in C, the kernel part should be something like this. We have to use triple loops to implement this. And now we have a question whether this routine is correct or not. There are certain bugs in it. For instance, they didn't consider whether the two matrices are matching. For instance, if you want to multiply two matrices, the row of the first matrix, so the column of the first matrix must be equal to the row number of the other matrices. So they didn't check this kind of thing. So there is a bug here. And then you can write something like this. You can check whether the column first matrix equals to the row of second matrix. You have to give a command like this to check. If it's satisfied, then we can perform multiplication. And if it is not satisfied, we can give an error message. So it seems that the problem is solved, but it is not solved. Because if we use this command, we neglected the case where the two matrices, one of the two matrices is a scalar. If it is a scalar, this condition does not satisfy. However, in mathematics, these two matrices can be multiplied together. So we have to add another if statement to check whether there are scalars in the matrices. So we have to use more statements. And if we add those statements, that's not enough because A or B matrices might be complex matrices instead of real matrices. If it is complex matrices, then the aforementioned program may fail. So we have to consider many of these kind of things. If you neglected one part, then the program might contain errors. Sometime in the future, it will return error results. So in the low-level programming, there could contain errors, but in Matlab, what we use is C equals A times B. If they are not flexible, then we can get the result. If they are not compatible, then there is an error message. So that's all. A and B could be complex matrices as well. So if you use Matlab, you do not have to concentrate on the low-level things. What you need to do is to use standard command and then concentrate on other high-level thinkings, just as Professor Chen talked about the computational thinking. You do not have to spend too much time on low-level things. Here is another example. If you are expected to get a Fibonacci sequence, and you know the Fibonacci sequence, the first two terms are 1, and then the other terms can be calculated in this formula. So it seems quite simple to implement this kind of problem in C, and these are all the code you need. It seems that this one can be implemented easily. However, if you are trying to execute the program, you may find errors. After 10 terms or 11 terms, don't remember, you will get negative numbers. The first thing you can strange. Why? Because we use the data type of int. So it is limited by I think 30,000 or something. So if the value exceeded that the range it will be converted to negative and then back to positive or negative alternatively. So if you are using C, you may find error results. And I think you can solve this kind of problem easily by replacing this one with more phase. For instance, you change this one to long, seem to have solved the problem. However, if you change it to long, you can only remain the positive ones for about 20 terms, and then you can negative terms again. So if you use C language or other low-level languages, you will get some kind of tedious problems, and you have to try to solve this problem. If you cannot solve them successfully, you will get the wrong result. However, in Matlab, you can solve this kind of problem easily. So these are the mathematical libraries, low-level mathematical libraries being still used. And now, the leading edge, the new one, LaTeX, can be used to replace the other packages. And the target of LaTeX is no longer provided for average users. It's provided to support the commercial or high-level languages such as Matlab and other languages. So to solve this kind of problem, we better use Matlab or other high-level mathematical languages. So let's make a summary on computer mathematics languages. I have already given you a very brief review of the development of Matlab. In 1980, Professor Chen, who started writing the Matlab matrix laboratory, named it Matlab. And then it was a free software. It contained about 30 commands. Most of them are for numerical algorithms. So numerical algebra, linear algebra. And in 1984, Jack Leto, who is the CEO of Matlab, founded the company and developed Matlab. And they provided the first release. It become a commercial package. And the program becomes stronger, the language becomes stronger and stronger, and it will be released twice a year. And they now name the versions by A and B. For instance, the first version of last year's version is 2008. So I will recommend you to use this one for symbolic computations. However, for other computations, if possible, you can use new ones because there are new facilities in the new versions. For symbolic computation, you cannot use new ones because some of the commands in the book or in other applications may not work. Apart from Matlab, there are several other